So I don't want to brag too much, but I actually am kind of a big deal in this community. You might remember me from episode 119 of Elixir Talk. I sent in a suggestion that Desmond and Bowie liked so much. Chris and Desmond. Chris said, my first feeling about this is that it's all wrong. So we're going to make a couple of just like quick adjustments to the talk here. There was nothing specifically in the email about coming and talking here that I couldn't change my talk. So, all right. So our plan we're going to be flying by some stuff. The point of this talk is that if you've ever thought about nerves, but you don't know where to start, or you don't have a problem that you think nerves can solve, I'm going to try to prove that there's something pretty easy that you can do in about a weekend with no specialized knowledge and without a whole lot of trouble. But in order to give you a lot of examples, I'm going to kind of fly by them. So I'm going to have links in here. I'll tweet out a link to the slide deck later. And a lot of these ideas have been written up in blog posts, and so there's more detail available. If all else fails, just talk to me on the internet. I'll talk to anybody about nerves for however long you want to. So starting off with Blinky, this is kind of the hello world of a nerves application. We're going to buy ourselves a couple pieces of hardware real quick. We're going to buy one of these Raspberry Pi 3A Pluses, $25. Got to get yourself a micro SD card and something so that you can write to it, like a little adapter. On your console, you're going to install Nerves Bootstrap and then do mix nerves.new. That's going to generate a little project structure for you. We're going to immediately add two dependencies, so Nerves Init Gadget and Nerves LEDs. And without going into all the details, Nerves Init Gadget basically gets you to the point where you have a Wi-Fi enabled device. It's ready so that you can SSH to it. You can also do things like get to it. It'll MDNS publish its location so that you can easily find it on your network. You can send it updates over the air. So we're going to provide a little bit of configuration for that library so that it knows what you want the device to call itself. It knows what SSH key to use to authorize access to it, and some environment variables for what Wi-Fi network it should join and what passkey it needs to use. You do that much, and then you can compile and firmware burn. So you put the SD card into your laptop, you run these commands. A few seconds later, you have a 20-ish megabyte or 30-ish megabyte image written to that SD card, and that is your Linux kernel, your Beam, your project, everything all in one. So you plug that into one side of your Raspberry Pi, you plug some power into the other side. Adobe Photoshop skills, I also do some consulting there if you're interested. Now you can ping from your laptop, ping blinky.local, and it may not work right away because your device is still booting, but pretty soon you're able to ping that thing, and you can just say SSH blinky.local, and you are on an IEX terminal that's running on your Raspberry Pi device. This took you like around 20 minutes maybe if it's your first time doing all this stuff, and your laptop is slow and your internet connection is slow. All those things happen, then you're looking maybe 30 minutes, and you actually have a pretty amazing development platform up and ready to go at this point. So all we're really going to do with that is we're going to go back to our application EX file. We're going to put in a little thing that whenever our application starts, we're going to set this one LED, our status LED, to do a fast blink or a slow wink or whatever you want. And now we're going to do mix firmware.push to blinky.local. And this will build a new image, but it's going to SSH connect using your SSH key and send that new image over the wire. Your device will accept it, write it to disk, and restart itself with the new version, and now you'll start to see your status LED blinking the way that you chose. And this is where you realize that your bar of happiness is really low, because all you've done is turned on a really small LED, and all it's doing is blinking, but you're going to feel amazing because you made that happen. So at least I do. So Blinky Project 1 is done. What we have is about $30 of pieces, 1 to 2 hours of work, and you have all this stuff ready to go, which is a really amazing starting point. So we're on to project number 2, and this one has a little bit of a story. So these are my 3 kids a couple of years ago. This is what they looked like. And this one little citizen right here had developed a habit of waking up somewhere between 4 and 5 in the morning and coming downstairs and wanting to play with mom and dad. And this did not go over well for the overall family happiness. And so we were starting to try to problem solve, like, okay, how do we help him work through this? How do we try to support him without yelling because it's 4 in the morning? So first thing we did, we go to Amazon, we buy this little thing, because he can't read a clock. He was only 4 and a half. he doesn't really understand clocks, but we're like, all right, we find this thing where it turns green at a certain time. And the way you set what time it turns green is that you push and hold a button on the bottom for 10 seconds. This is great. It's easy for us to set up. It's called Honoru, which is like the cutest name I've ever heard. So we put it in his room, and we tell him, hey, when Honoru turns green in the morning, that's when it's time to come downstairs. If you wake up before then, go back to sleep. No one wants to see you. But I kid you not, the third night that this is in his room, he realizes that if he pushes and holds the button on the bottom of Honoru for 10 seconds, Honoru sets the time and turns green. So he came down at 5 in the morning with Honoru green, and he's like, guys, let's play Legos. So my wife turned to me, and she said, honey, I need you to write a cryptographically safe alarm clock for our son. And so I said, all right, Amazon, here I come. I buy myself some breadboard jumper wires, $7. I buy myself a pack of colored LEDs. I go to pinout.xyz. If you do any Nerf stuff, this is going to become your new favorite URL. It just shows you, it reminds you what all the pins are. And all we really need to do is we're going to connect one of these green pins. That's a GPIO pin, meaning that you can set whether it has voltage or no voltage on it. You're going to connect that to the long side of one of the LEDs. You're going to take the short side of the LED and put a jumper wire to a resistor and then to the ground on one of your ground pins. You're going to do the same thing with the green LED. And then you're going to add the Elixir ALE dependency to your project. It even has like a little diagram of how you can do this with an LED. And in our application, we're going to start a couple of children. So we're going to start some GPIO supervised children and name them red and green. And you can now use whatever, you can use SCEDX or whatever you choose to use in your project. But you can basically now turn on the green light or the red light whenever you want. And we set it so that at 5 a.m., the red light turns on, meaning if you wake up and roll over and see a red light, stop what you're doing and go to sleep. And if you roll over and it's green, then it's time to come downstairs. You got the green light. So now we've spent $42, around 2 to 4 hours. You have a customizable schedule, totally not hackable by a 7-year-old or a 5-year-old, and you got some more sleep back. Like, we got hours of sleep back into our lives on a daily basis, which is priceless. Also, it was nice because my son ended up helping me to Dremel off some pieces for the case, and he now thinks that he can build anything in the world. So that's a big pro. So next project, we now have the ability to turn things on and off. With this new ability, I immediately thought, man, my sprinklers could use an upgrade. Our HSA contacted everyone in our neighborhood. There's a drought going on in Utah. And they're like, hey, we're going to have these new rules for which houses can turn on their sprinklers on which days to help conserve water. But I had a sprinkler system with a really old school dial thing that you turned, and I couldn't figure out how to set the schedule I wanted. So once again, my wife was like, honey, we need to solve this with Elixir. Please, can you go buy some devices and solve this problem for me? So really quick introduction to sprinklers. Turns out that the way sprinklers work, the thing that's in the ground, it always has water pressure on one side of it. And if you put 24 volts AC power to it, all it does is open that valve and water comes out the other side. That's literally all sprinkler controllers do. So mine looks like this. You take off the front panel, it looks like this. And all that actually has to happen is in this top left corner, that thing is 24 volts AC. And if I can connect that 24 volts AC to one of those pins along the bottom, each one of those pins along the bottom is one of the zones of my sprinklers. And all I have to do is connect those two. But 24 volts power is too much for a Raspberry Pi. So we're going to buy one thing for this project. We're going to buy an 8-channel relay. And each box basically becomes a programmable pin connector. And so you can plug in 2 wires to each of those boxes. And then from your Raspberry Pi, you send one little signal and just say connect or disconnect. That's all it does. So we wire that up to one side. To the other side of this, we take in that 24 volt from the top left of the sprinkler controller. We connect each one of these boxes to a different zone of our sprinkler system. Voila, you have working things, except that I didn't have the time zone set correctly, so they went off in the middle of the afternoon at a really weird time. So figure out time. But there's a package called Nerves Time, and it'll NTP the correct time on your device. And then you're off to the races. Bonus, while you're messing around in your garage, you may find a lizard, which one of your sons love, and your other son, while you're messing with the sprinklers, might find out that water bottles fit perfectly on the end of a hose and turn into water rockets. So Second to last project, garage door sensors. One day we leave in the morning and we close all the garages and we go to the museum. We're gone for hours, and when we come back at the end of the day, garage door is wide open, and it's been open who knows how long. And so maybe one of our neighbors is on the exact same garage door setting that we are or something. Maybe something else happened. Who knows? My wife's like, honey, I need you to be the hero of our family, and please program something to solve this problem. So buy more breadboard jumper wires, go buy yourself a magnetic Hall effect sensor. The hardest part of this project by a long distance is not anything with the code or the sensors or anything else. The hardest part is that your garage doors a lot of times are nowhere close to a plug. And so you either have to get some long wire to get power so that you can put the Raspberry Pi close to the door, or you have to get some long wires to connect the sensor to a place that you can plug in your Raspberry Pi. Solve that however you choose. But once that's done, essentially all you're doing is you're connecting these 3 wires from the side of your Raspberry Pi to this magnetic Hall sensor. You take one of the magnets off of the front of your fridge and put it on the side of the garage door that moves, and you put the sensor on the part of the wall that doesn't move. And when they come close together, then you know the garage door is closed, and it's going to turn the voltage on that one pin high. So we're going to use the Elixir ALE project again, but this time what we're going to do is we're going to wrap it inside of another gen server. So we're going to start one gen server whose job is going to be to notify us about when the garage door opens or closes. And that one will start another GPIO on that pin, but read it as an input instead of an output. And I'm using this GPIO set int, and that basically means send me a message whenever the state of that thing changes. So we do that, hook it up to a little bit of a Phoenix web interface. If anyone ever wants to know how my garage doors are doing, go to this URL. And I added one signal has a little thing so that you can do push notifications fairly easily. And so I can go on my phone and subscribe. You guys are all welcome to subscribe to what's happening with my garage doors if you want to. I got a little notification this morning when my kids were going to school. So now my kids are thrilled. They think I'm amazing, and I've spent $45 plus one big wire, and I have another problem solved. And now my last project. So my kid, who's now 7 years old, for Christmas, he wants a Nintendo Switch. And there are a whole mountain of reasons why this is a bad idea, for him particularly. But we really don't want to just tell him that Christmas is not true and that he cannot get games. So instead, I'm like, OK, what we'll do is he and I will build a game together. So I go buy a Raspberry Pi touchscreen, 7-inch touchscreen. I buy a little case for it that lets you mount the Raspberry Pi in the back. This is actually over by the door if anyone wants to go play with it later. And for this project, most of the ones you can just use whatever little USB cable you have lying around the house, and the power's going to be fine. But the touchscreen actually uses a fair amount of power. So for this one, you probably want to buy a power supply. So everything comes with these things, like all the mounting screws and everything. So you get that mounted together. You add Scenic's driver nerves touch and Scenic driver nerves RPi, which is how Scenic knows to paint the picture to that type of screen and how it knows to receive the touch events from that type of a screen. You add a little bit of configuration so that it knows where your screen is. And then you follow this blog post, because I do not have time to go through everything about Scenic. But basically, this blog post does all of it and was how I first learned Scenic. And with that done, you spent way too much time and way too much money on a gift that turns out to be a lot less fun than Heelys. So your 7-year-old does not think you're actually that amazing after this project. But I feel really amazing, and the snake game is over there in the corner if anyone wants to go play. And so now at the end of all of this, we've built 5 projects. There's a whole bunch more you can build if anyone wants to talk about fun projects to build. But a lot of people have asked me, why? What's the point? Why should I spend any time actually learning this? And I mean, there are reasons, but suffice it to say, it's just fun. Literally, that's the only reason I've done any of this stuff, is because every time a light turns on or off, because of a piece of code I write, it feels amazing. And I feel so cool, and my kid cannot hack his alarm clock, et cetera, et cetera. So that's the end. There is a little Nerves meetup group that's remote, and so we get together about once a month. If anyone is interested or trying to start a project or has questions, the Nerves channel on the Elixir community Slack is really responsive. It's a great place to get help. But also, if anyone wants to jump in here and get some guidance on a project you're working on or ideas about how to accomplish something you're thinking about, let us know, and we'd be happy to talk with you. So that is it. Thank you.